This video is going to show you some of the math associated with free body diagrams using the method of substitution. I've got a problem here, and the problem had two free bodies. It had one for all these two summations, and it had another one for these two summation equations. In this problem, I knew I wasn't given the friction, the tension, and the net acceleration, but I have m1, m2, g, and mu. What I need to be able to do is I need to be able to rearrange these to find a net using only my givens that are up here. So I got to get rid of friction and tension. Now there are a couple things to notice right away. I've got friction and I've got a normal force. And what that tells me is I've got a third equation with substitution. I have F is equal to mu times eta. That's the definition of friction. So that'll allow me to pick one equation into the other. And I have two tensions. So in this problem it probably had one rope and two tensions because equal and opposite pulls. So with these two tensions I can set T equal to T. In other words, I can take one of these equations, either one, solve it for t, and take that equation and substitute it in for the other t. Remember, it's the method of substitutions. So let's see. I've got to find a net. So I'm going to start with getting rid of the friction and the normal force because I have mu up here. So F is equal to mu times eta. What I'm going to do next is I'm going to take mu times eta and I'm going to replace it or sub it in for the friction. So that's going to become m1a, a net actually. But I'll leave it as m1a. It's equal to t minus mu times normal force. Great. Now let's substitute for the normal force, get rid of that. So what I'm going to do is I'm going to take this second equation and I'm going to solve it for the normal force. So eta, although it says n1, but there's only one normal force. So eta is equal to m1 times g. Now, remember, method of substitution, so all I do is to substitute. I'm going to take this expression, m1g, and put it in right there in the equation. So now the equation looks like m1a is equal to t minus mu m1g. Now I still got to get rid of this t. And I'm solving for the a that's in there. I got rid of friction already, but I still got to get rid of the t. To get rid of the t, I'm going to take a look at this other expression over here. And on this other side, I'm going to take this expression here, and I'm going to solve it for t. So that's going to be t is equal to, in this case, m2a. Kind of got ahead of myself there, didn't I? Yep, I definitely got ahead of myself there. So let's erase this and try over again. Alright, so let's see, I'm gonna say 0 is equal to m2g minus t minus m2a, and then I'm going to take the t and move it to the other side, so that's going to become t is equal to m2g minus m2a, and again this is just this equation down here is all I'm doing. So now I have an expression for t. What I'm going to do is method of substitution. So I'll take this big expression here and I'm going to put it in for the t. So now m1a is equal to m2g minus m2a minus mu m1g. Great. I got rid of the mu's. I got rid of the t's and the f's, and I got a in there. So now all I got to do is put a on the same side of the equality sign and isolate it. So I'm going to add m2a to both sides. So that'll give me m1a plus m2a is equal to m2g minus mu m1g. Now I use the distributive property to pull out the a. So a is equal to m1 plus m2, and that's equal to m2g minus mu m1g. Divide both sides by the quantity m1 over m2. So I'm running out of room here. I'll go up here. And this is going to be a is equal to the right hand side, which is m2g minus mu m1g, divided by the expression in front of a, which is m1 plus m2. And there we go. I got an expression for the net acceleration in terms of the given variables.